Welcome to EMEE6002 Sustainability Climate Change. This topic is carbon capture and storage. So when we have already emitted carbon dioxide to the atmosphere, or when the power plants have already generated carbon dioxide, can we capture and store this carbon dioxide in a tank and then dig a hole and put it under the ground instead of letting the carbon dioxide to escape to the atmosphere and create greenhouse effect? Therefore, scientists and engineers have developed a solution to capture carbon dioxide from a large pond source, for example, the fossil fuel power plant, so that we can put those carbon dioxide into a confined area and then dig a hole under the ground and store those carbon dioxide in geographical formations. The aim is to avoid large amounts of carbon dioxide from releasing to the air so that we can avoid the greenhouse effect, and also is a mitigation of the climate change and global warming. The whole idea is to avoid releasing carbon dioxide to the air and then put carbon dioxide under the ground so that carbon dioxide can be stored in the ground foundations. Let's see this video to see how it works.
Climate change is a big problem. Land clearing, intensive farming, burning fossil fuels like oil, natural gas and coal. These human activities all produce greenhouse gases. We need to slow down and reverse global warming, and it's gases like carbon dioxide or CO2 that we need to reduce. The Australian coal industry knows it plays a role in the problem, and we want to play a role in any climate change solution. That's why we're investing $1 billion in carbon capture and storage. It means we capture the CO2 emitted by burning fossil fuels, compress it into a liquid which is transported to a storage site, then store it safely and permanently deep underground. There are hundreds of active carbon capture and storage projects worldwide. Those are the three main carbon capture technologies: pre-combustion, post-combustion and oxy-fuel. The captured CO2 is what scientists classify as inert, meaning it's like many naturally occurring gases, very stable. After the CO2 is captured, it's compressed at high pressure. This turns it into a liquid. Once in this state, the liquid is transferred to a suitable storage site. If it's close by, trucks are used. If it's further away or large volumes are being transported, we use pipelines. In the US alone, there are pipelines stretching thousands of kilometres, and they've been safely transporting CO2 for enhanced oil recovery for years. The next step is storing it safely and permanently in deep underground rock, a process known as geosequestration. Storage sites are carefully chosen. We select ones with vast stores of porous rock deep underground. This porous rock is like a sponge, filled with millions of microscopic holes. As we inject the liquid CO2 into porous rock, it spreads through the gaps and fills these holes. Directly above this porous rock is an impermeable layer. It's non-porous, meaning it has no tiny holes. It acts as a cap that the liquid CO2 can't break through, trapping the CO2 from escaping. It mimics a natural process. Hydrocarbons like oil and natural gas have been doing this for millions of years. Over time, the CO2 can be dissolved in salty non-drinking water, or react chemically with surrounding rock, producing stable carbonate minerals. We're also trialling storing the carbon in saline water-saturated rocks, depleted oil and gas fields, and coal seams. So the carbon is captured, transported and stored safely away from the Earth's delicate atmosphere. But the process doesn't end there. A sophisticated monitoring system is in place to keep track of our stored CO2. Monitoring is done on 3 levels: the subsurface, the soil, and the atmosphere around the site. Capture, transport and storage techniques have all been successfully used for many years. The challenge now is creating a fully integrated system, one which can be built into new power plants and bolted onto the existing ones. Think of the difference this will make. Successful carbon capture and storage projects are underway all around the world. They're a critical part of any solution to climate change.
In this video, we know that there are 2 ways to do carbon capture. One is by the absorption by a chemical. Another way is by the membrane gas separations. We can make use of a chemical called amine to capture carbon, The carbon dioxide from the power plant will then first cool by water and then pass through this chamber where it is mixed with a solvent. And these solvents will absorb carbon dioxide and then pass through a separator. Then this solvent and carbon dioxide will be separate, and then CO2 can be stored. And the solvent is called amine, which is the orange molecule in this diagram, and the blue molecule in this diagram is carbon dioxide. So carbon dioxide from the power plant will mix with amine, and then these combined molecules will pass to a heat separator. So amine and carbon dioxide will then be separated by heat. So amine will then be recollected and continue the cycle to absorb other carbon dioxides. And the carbon dioxide separated will then pass to a collector so that we can store this carbon dioxide. As shown in the video, we can liquefy carbon dioxide and then store in the geological formations, or it can be stored in form of mineral carbonates, for example, the limestone calcium carbonate, which is relatively stable. And although in theory, we can also dissolve carbon dioxide in the deep ocean, but this is not considered as feasible, because if we dissolve carbon dioxide into the oceans, it will make the ocean's water more acidic, and this is not favorable to the coral and sea life. So geographical formations is probably the most promising technologies nowadays, and according to the National Energy Technologies Laboratories in America, their capacities for carbon storage is more than 900 years. And there may be a long-term problem that even though we store carbon dioxide under the ground, but in the long term, there may be still a risk that the carbon dioxide may still leak to the atmosphere. In general, there are three types of carbon capture, namely post-combustions, pre-combustions, and oxy-fuel combustions.
In pre-combustion capture, coal is combined with oxygen to create a gas. It's made up of carbon monoxide and hydrogen. Adding water to this gas causes a reaction. It converts the carbon monoxide into hydrogen and CO2. The CO2 can be safely captured, while the hydrogen is burned to drive a turbine and generate electricity. It can even be used to feed fuel cells for cars. In post-combustion capture, the fossil fuel is burned as normal. But before the flue gas travels up the chimney, it passes through an absorber column. This is filled with liquid solvents called amines, which absorb the CO2 before it can enter the atmosphere. Superheated steam is then passed through the chimney. This releases the CO2 from the amines, and it can now be safely captured. The last of the key capture methods is the oxy-fuel process. Before combustion, nitrogen is stripped from oxygen in an air separator. The leftover oxygen is then purer than the normal air we breathe. When combusted with a fossil fuel, it produces CO2 and water vapour. This combination is put through turbines to generate electricity. Afterwards, the water vapour is cooled, condensed and removed, and the remaining CO2 gas is safely captured.
Post-combustion is used to remove carbon dioxide from the fossil fuel power plant. So the fossil fuel and air will mix and heat together in the combustion process to generate power. And after this process, the emissions will be mainly carbon dioxide and water vapors. So the problem is how to remove this carbon dioxide after it is generated by the fossil fuel power plant. So this is what we call the post-combustions, after the combustion process. So carbon dioxide can be absorbed by these technologies after it is generated from the existing power plant. So this is what we call a retrofitted solutions to solve those problems that's already created by the existing power plant. So the power plant is there already. Another way is called pre-combustions. This time we try to take away the carbon content from the fuel. So the fuel will gasify, and also we take away the carbon by introducing oxygens into this fuel. So the fuel plus oxygens, we extract the carbon content, and then carbon dioxide will be extracted before this fuel is fed into the combustion chamber. So the remaining elements in this process will be mainly hydrogen. So we extract the carbon from this hydrocarbon by oxygens. So the carbon content will be extracted into carbon dioxide and we collect and store it. And the remaining content will be hydrogen. When hydrogen is burnt in air and heat in the combustion process, the main output will be water vapor, which is clean and no greenhouse effect. And the carbon dioxide that are collected can be stored in the method that we have mentioned above, and it can help to reduce carbon emissions by this process. Another method is called oxy-fused combustions. So the fuel will mix with pure oxygens. So we extract oxygens from the air and take away the nitrogen. So with plenty of oxygens in these combustions, so the fuel can be burned completely. And any coal fuel gas is recirculated and injected back to the combustion chamber. So if there's any incomplete combustions, then it will be recycled until all the fuel are burnt. In this case, almost the pure carbon dioxide can be collected and then stored for carbon storage. So this is the way how we can avoid emitting more carbon dioxide to the atmosphere by these three processes, namely post-combustions, pre-combustions, and oxy-fuel combustions.